Recently I made an attempt to cut some clock gears on the Multicam CNC router, only to discover that the gears were seriously out of round. The sample gears, if we look at them on the optical comparator, it's very obvious. It looks good in the x-axis, but the y, not so much. Even with the stepper locked, I could move the head back and forth on the CNC router. It shouldn't move, it should be tight. While moving the head back and forth, I verified the belt wasn't moving, and it looked like maybe the pinion was turning on the shaft. Upon disassembly, it was clear that the pinion was worn badly. There were the cross hole for the roll pin was worn. It could also move on the shaft, and that movement over time has caused the cross hole to wear and the shaft itself to wear undersized. Both bearings need to be replaced. The upper bearing was exceptionally bad, and the lower one wasn't much better. It definitely contributed to the wear of the pinion and shaft. After kicking around some ideas, it was decided that we could probably nickel plate the shaft and then grind it down and recover it. And so here I am at the lathe. I'm just getting it set up in a collet, double checking to make sure that everything's running nice and true before I center drill it. The shaft will need to be center drilled so that after the plating process is complete, it can be held between centers and ground concentric. And so here I am with a center drill and just putting that feature into the shaft. It was center drilled on one end, but not on both ends. Next, the part was bead blasted in preparation for electroplating. Any features that you want to protect from plating need to be coated with some kind of resist. So here I'm using some nail polish, and I'm coating the ends and also the knurled portion to prevent the electroplating from plating those areas. In electroplating, a small DC electrical current is passed through an electrolyte solution, and it causes the nickel to be plated or deposited on the surface of the part. Here I'm putting the part in the solution and hooking up the electrodes. Now for a quick lesson about electroplating. The process is fairly simple. The positive and negative connections are generally referred to as the anode and the cathode. The anode, or positively charged electrode in the circuit, consists of sacrificial metal plates that will form the coating. In this case, they are pure nickel. The cathode, or negatively charged electrode in the electroplating circuit, is the part that needs to be plated. It is also called the substrate. When the electricity flows through the circuit, the electrolyte splits up, and some of the metal atoms it contains are deposited as a thin layer on the cathode, and it becomes electroplated. Inversely, some of the atoms on the anode are taken up by the electrolyte. Over time, the anode will be completely consumed by the process. All kinds of metals can be plated in this way, including gold, silver, tin, zinc, copper, chromium, nickel, platinum, and even lead. I used a piece of brass wire to make the connection, and I taped up any areas of the rod I didn't want to have electroplated, and this worked out fairly well. Next, it was just a matter of setting up the surface grinder to do the cylindrical grinding. And the first thing that you need to do is move your stops and lock the table. And on this particular machine, it has a really nice setup. It has this locking block, and you'll push your stop blocks up against one side and then push up against the other side, and your stop blocks will hold it against that pin, preventing the table from moving back and forth. And here's a close-up of the locking mechanism. Next, you'll want to dress the stone using the diamond dresser, and it's a pretty simple process. You're simply going to make sure that the block is clean and make sure that your magnet is clean. Slide the block on from the edge and just pick a spot under your wheel. I tend to go, try to find about the center. Lock the magnet so it holds it down. Next, bring the wheel down to where you're close to the diamond. You want to be careful not to crash into the diamond. So, leave yourself about 1/8 of an inch. Start the spindle so the wheel is running, and you're going to very slowly bring the wheel down into your work. Each graduation on the wheel brings you down 1/1000th of an inch. So I tend to look until I'm close, and then I'll hold my hand behind the wheel and I'll feel for the debris. You just want to barely touch it. Move the table in and out across the diamond so that the diamond can dress the stone or make it flat. This does a few things. It makes the wheel concentric, makes it flat, and it opens the pores so that it cuts more efficiently and generates less heat. Continue bringing the wheel down into the dresser and running across until you're happy with the surface that you're left with. It should be uniform in color, indicating that it is now flat and clean and ready to go to work. The fixture I'll be using to grind the shaft is called a SPEEDY-SPINNER, and it's basically very similar to a bench center. You can mount the shaft between two dead centers, and it has a hand wheel that you crank, and you can crank it opposite the direction of the wheel so that it grinds it in a very concentric fashion. It's driven by a dog, and here you can see I'm installing the dog on the shaft, and this will turn it when it's on the fixture. The centers are then greased with some lubricant, and this lubricant is designed specifically for dead centers, and as it warms up it becomes very smooth, and you'll see during operation that the centers operate with little to no friction at all. The tailstock is spring loaded, facilitating the installation and removal without moving your end supports. After the shaft is installed between the centers, go ahead and lock the tailstock with the Allen key, and there are 2 screws, and so just snug those up. They don't have to be super tight. And then we're going to loosen the screw on the hand wheel arm, and this will allow us to rotate the hand wheel up into a position that is comfortable for us, and it's movable because it needs to fold down to fit in the box, but then during operation this gets you up off the table and just makes it a little bit more comfortable to use. So pick a spot that you're happy with and then lock it with the set screw. The hand wheel has an arm that folds out and gives you a little bit more leverage, and so just go ahead and give it a spin. Make sure that it feels good. You don't feel any resistance. It should feel buttery smooth. So I put a test indicator on the shaft to show the run out, and it appears that there might be a slight bend in the shaft. Use your bare hand to clean off the magnet. It tends to pick up material without leaving lint like a cloth or a paper towel might. Next, slide your fixture onto the magnet. You want to come on from the side so that you don't trap any particles or anything that might remain between the fixture and your magnet. After moving the fixture to your desired location, engage the magnet and make sure the fixture spins without hitting anything. I like to apply some DYKEM layout fluid to the shaft so that I can get an idea of how my cut is progressing, and it'll let me know the taper and all of that. In total, I attempted the nickel plating grinding process 3 times before I finally decided that I would try something else. On several of the attempts, the nickel plate actually broke away, leaving the shaft, with bare areas. Here on my final attempt, everything is going really well. I'm taking about 1,000th per pass, so about half 1,000th per side, and it's looking really good. I get right down to the end, and I'm on dimension, and it cracks off the end. It's disappointing to have the nickel fail. I'm not sure why it's not adhering well to the substrate. It may be possible that copper plating it prior to the nickel plate would help. I've put about 10 thousandths material on, tried a few different preparations, but I think we're just going to have to remake the shaft. Up next, part 2, making a new shaft. Thanks for watching.